All right. Just before we actually get into today's lesson, I want to talk about some things just to help basically mediate confusion. What I've found with the other two classes so far is that there's some common issues that we're having with getting proper files loaded, getting things like that working, and really the biggest issue, the reason why there's an issue, is just not understanding how the Apache server or MySQL server works. So I feel like if we explain that, help you fully understand how this thing is working, then it will help you understand where your files need to exist in order for everything to be okay, okay? So I have a small write-up on it. If you go to your Lesson 3 folder under Blackboard, so just navigate to Lesson 3. Don't worry, guys, you haven't missed much. Lesson 3, you're going to go to this link at the top called Capturing and Selecting Data. So go ahead and click on that link. That'll take you to my lesson plan folder. The top thing you will see there is understanding Apache and MySQL servers. And I will attempt to explain how all this actually works. First question though, how many of you took the networking class? Awesome. So you'll remember in networking class, did you guys set up a server in networking class? No? Okay. But you set up little network routers, right? And you learned how to plug in the Ethernet and open up ports. Did you guys learn how to open up ports? Well, the good news is that little network router, congratulations, you were working with a server because that's what that little network router was. That's a server. And that little server controls a whole bunch of different ports. It's an extremely simple server. Its whole purpose is to literally just listen to traffic coming in and make sure it routes that traffic to the appropriate destination. That's all it does. In addition, it has some security features to make sure that, bad traffic doesn't come in and attack your computer, or bad traffic doesn't go out and attack the internet. It will stop those things from occurring. Obviously, it's not 100% foolproof, but that's what it is. That little network router you guys were playing with is a server. That's its purpose. So a server, all servers work the same way. They all literally do the same operation. They listen to traffic coming in, and they route it to the appropriate port based on what the traffic is actually requesting, right? So a server does exactly as its name implies. It serves information. What it serves depends on the type of server it is. The two servers that we're working with are Apache and MySQL. Those are our two servers, right? When you're in Andrew's class or Ben's class, you guys are generally just working with your MySQL server. When you're in this class, you have to boot up the Apache server as well. So what is Apache? Apache is known as a web server. Its whole purpose is to be able to take code or stuff you've created and serve it to an internet port that you've chosen, to a web port. The Apache that we're using locally, it basically takes any information we request on a path and delivers it back to the browser that we requested on, and it does that through the path known as localhost. Localhost is known as a domain name. That's its purpose. There is actually no such thing as localhost. That thing itself doesn't mean anything. It has no representation. It's an alias, right? It's an alias for something that does mean something, which is known as the IP address. The IP address, think of it like a street address for your home, right? Your street address for your home is unique. It defines your house, right? It defines where your house is located, what city your house is in, what province or state your house is in, and what country your house is in, right? And those details, those 4 to 5 details that you have in your address, uniquely identify you as existing at that particular location. IP address, no different. Same idea. The IP address says this computer exists here. And it's unique, right? Everybody's internet incoming IP is unique. No one has the same one. In fact, it's such an issue that most internet service providers don't give you the same IP all the time. Actually, every few days or every few months, they'll rotate your IP and give it to somebody else. It's not reliable. Those are known as dynamic IPs, meaning they change, right? They're not always yours. And you can force that too. You can actually tell your computer to tell your internet service provider to issue you a new IP. But the IP is important because it's what defines where something is located. Websites, well, they don't have to live on a static IP. It is preferred they live on a static IP because you want to be able to get to them. If you don't have a website on a static IP, you need something called a dynamic router, which basically keeps track that your address has changed. Most people want it on a static IP. But again, the domain name, so when you go to google.com, that is just an alias. Localhost that we'll be using is just an alias. It's an alias for a very famous IP address that maybe you guys already know, 127.0.0.1. How many of you have heard of that? Or rings a bell of any sort? One person. That's surprising because you guys had an IT class. that should be definitely something they would have talked about. Anyways, 127.0.0.1. I said to you that IP addresses are unique. They're unique outside of our network. All the addresses outside of our network reaching out to the internet and retrieving information from the internet are unique. Internally, in our network, each one of your computers right now has been assigned a unique ID by Georgian. You each have an IP address that's unique based on something that Georgian's given you, usually within a range. That is important. However, locally, on your own personal machine, the local address that isn't actually doing any internet traffic whatsoever, your local environment for Apache is all the same. Every one of you shares 127.0.0.1, except for you Mac users, because XAMPP is providing you some sort of weird IP address. But all you Windows users will be using the exact same address, 127.0.0.1. Now you may be asking, well, if I have this IP address and it's giving people the ability to connect and look at my files, what kind of protection do I have, right? So when I'm on the intranet and I've deployed my website and Apache's like, hey, everybody, come see my website. And everybody's like, cool, of course you're going to get the hackers, right? The hackers are out there, those evil people that wear those white, Guy Fawkes masks. They're going to come in and they're going to go, I'm going to look for your bin folder. I'm going to look for your exe folders. I'm going to look for your program folders. I'm going to get into your registry. I'm going to do anything I can to contaminate your computer with viruses. Here I go. So you're like, well, what protection do I have? How do I stop that? If I have an Apache server that listens to internet traffic, what is protecting me? Well, the good news is Apache says, I will only give access to the folders you tell me I'm allowed to give access to. So you, as the developer, can explicitly state what folders the internet is allowed to access and say these ones are not and these ones are. And the good news about it is once you landlock and tell Apache what server is available, what folder is available, it can't go up to the parent directories. So a user can't try to reach up and get outside of it to other folders. In addition, you can actually blacklist accessible folders and say, you can't access my bin folder, you can't have my CGI folder, you can't have this folder that I use to store flat files. You can't access those folders. And what will happen is as they're trying to access those folders, Apache will keep throwing them 404 errors saying, no, you can't access those folders, right? So because of that, we have to be considerate of where we put our files, because when we install WAMP, it actually does that for us. It configures all that stuff for us. So that's the good news too. You don't have to configure it. But because of that, that means our files that we actually use in this class have to exist in a specific folder. They have to. What I have had in the past with some of the other classes is people will download the starter files and expect them to work from their downloads directory. You wouldn't want that. right? You wouldn't want somebody to have access to your downloads directory. You want your files to live in the WAMP folder only, okay? So, remember how I got you to pin that comp1006 directory on the side? Apache that is set up in WAMP is configured that only folders existing in this www directory are accessible from your internet browser. If they are not in the www directory, you cannot access them, okay? So if your files are in the WAMP64 folder or in the C drive or anything up the chain, they are inaccessible. You can't get at them through the browser. They're not accessible. Only the files within this directory are accessible. I can prove that. See this www folder, right? If I open up my local host and I hit enter, what's being delivered to me right now is the index file that's in that www folder. Let me see if I can access the www folder. I'm going to change my local host. I'm going to be a sneaky hacker. Haha, I've hacked. Oh, thwarted, right? Because I'm not allowed to access the directory above it. I can't access directories that I am not allowed to access. Sneaky hacker. Haha, no, thwarted again. Can't access your C drive. And the whole reason is because Apache is like, no, you are not allowed to access these things. It's not even a question of me being able to hack your local host, your access through Apache, access your configuration and hack it away. I can't do that. It's a physical switch that's like, no, you can't get internet traffic through this. You're only allowed to access the files in the www directory. So when I go to localhost, what file is actually being delivered here? The interesting thing is that Apache actually will implicitly, right? So it will automatically pick any file called index and deliver it. And it does it in a certain priority order. If you have an index.html file, that will override any other index file in that directory. If you have an index.php file, that will come next, okay? If you wanted to have index.js load, unfortunately it won't, but you could probably configure Apache to do some interesting things. But those are really the two that you need to be concerned about. One other file extension you might come across is .htm, but it's pretty dead. You don't see them very often. So this is loading this file because it's indexed. Interestingly enough, all these files in here also have an extra piece after them. They have a little dot, and then they have usually a few letters that follow it, known as an extension. Right now, you can't see the extension because my Windows is configured to hide files by default. Let me show you how to turn that on, because you as developers should always be able to see file extensions. That is something you need to understand and know. Inside your, here, we'll walk from the beginning. Open up File Explorer. At the very top, you'll see these tabs. You'll see Home, Share, and View. And notice as I click them, it pops open this little menu. We want the View tab. Under the View tab over to the right, you'll see File Name Extensions with a little checkbox beside it. Click on it, and now you'll notice, if you look at your recent files, there's all these weird extensions like .zip, .pages, stuff like that. You won't have .pages as a Mac file. Let's go to View again. Hidden items. Oh yeah, we want to enable hidden items. We want to enable hidden items because any file that begins with a dot, that's a weird one for some of you probably, you can have a file name with dot, and what that will do automatically, by default, it will explicitly hide it. So it will hide it away and nobody can see it. Well, you don't want that, because as developers, you guys are going to start using things like Git. Git begins with a dot. Git ignore, which is super important because it tells Git to ignore certain things. That begins with a dot. env, which we're going to use to protect our details, our security details. That begins with a dot. All these files are automatically hidden, which is going to make it super annoying when you're trying to edit them, right? So the way we stop that is we click on this hidden items. And now any file that's hidden will be viewable to you, okay? When you are clearing space in your computer, so important. Hidden files, actually I can show you because they're in the C drive. Hidden files, let's see, program files. I just need anything. Give me service files. Where's your system files? There we go, system 32. All right, it's hard to see on this screen because the screen doesn't do things properly. Generally, your files that are hidden will be slightly muted. They won't be as sharp and as rich as the other folders. They'll be slightly muted, and that means they're a hidden file. Don't delete hidden folders and files. In fact, if it has the word system in it, don't touch it, right? If it begins with a dot, don't touch it. Don't delete it, okay? The reason is because these files and folders are responsible for operating huge amounts of your system, and if you just go randomly deleting them, you're going to have a problem, okay? Actually, the best scenario is don't delete things you don't know what they are. That's the easiest thing. Oh, here we go. Here's some hidden files. This .ds store, notice it's slightly translucent. .localized, translucent. Desktop INI, translucent. Cool. So Apache delivers our files to our internet browser through the local host. Now we have that comp1006 folder that we put on our computers. If we want to access it, we're allowed to. Here's what it looks like. See, in this directory, I have this comp1006. Pretend this www says localhost, right? I'm going to copy this comp1006 word by clicking in this address bar, just the word, or actually Control C. Come up here, hit / Control V, and there's my directory. And that's the same directory that you see there. Oh, this thing's wigging out. There we go. Same directory as you see here. So what you're seeing right now is Apache actually showing you a file folder browser. And look, it mimics what happens in Explorer. Those two things are the exact same thing. I'll say that one more time. This thing is the exact same thing as this thing. What you're affecting in here will affect what's in here, right? When you read a file in here, you're reading the file out of here. Your browser is simply doing some interpretive steps, some rendering steps for you. All right. So Apache is going to read the files in that folder. Not only is Apache going to read the files in that folder, it's also going to load in binaries for you. So we're using PHP. Apache is the thing responsible for taking your PHP files, translating them, and then sending out the translation to the browser. It's responsible for that. You know you're allowed to eat. You don't have to hide it. You're like sneaky, like a chipmunk over there eating food. So that's Apache's responsibility. Apache's responsibility is going to decode those files for you and deliver them as HTML to the browser. So where does MySQL fit in the whole scenario? MySQL is a database, right? A database stores information. That's literally what a database is. Doesn't matter what database you're working with, whether it's Mongo, Postgres, MySQL, MS SQL, DynamoDB, HDoc, all these different huge databases that exist out there, they all do the same thing. They store data and they provide you a query language, a language to get the data. That's it. The server part of it basically exposes an endpoint for you to be able to connect to send your queries to, right? It also restricts access. It restricts access to different users so that only certain users can access the MySQL database. Hence, when you guys installed your database with Andrew and Ben, you'll notice that when you go to access it, you have a username and password. By default, the password is blank, but the username is root, right? That's the default username and password. Where I work, we actually have a very large application where we do scraping. We scrape what's known as SERPs, search engine result pages from Google. And because we need speed, we just want to grab the content from the page and shove it into the database. So we use Mongo. MongoDB is a flat file storage solution. So what we do is we scrape, we grab the file, dump it into Mongo. Grab another one, dump it into Mongo. Grab another page, dump it into Mongo. When we're done, we have these things called grinders. Grinders come up, go through the page, take the data out of the page, and write it over to Postgres, which is like MySQL. It's a SQL database. In addition to those two databases, we also have a short URL service. Our short URL service, who's used Bitly before? You ever used Bitly or at least heard of Bitly? Bitly allows you to take an address, give it to it, and it will return back a short URL for you. So we also have our own short URL service. We call them curls. And that system actually writes all of its data to Dynamo, which is another flat file type style database run by Amazon. So we have 3 different databases that we interact with on a day-to-day basis, and all 3 are very, very restricted and extremely secure. We're not done, though. I have 2 more that I have to talk about. We have another database called Redis. Redis is very interesting. Redis is a dumb database. That's not me making fun of it. That's what it's called. It's called a dumb database. It is simply key and value. That's all it's for. It stores an array of values under a key. We use that for jobs. We store a job in it. When the job becomes available, we pop it off and we complete the job. The last database we have is called SQS. SQS is a triggering database, which is super interesting. Basically, you add a message into the database, and then it will auto-trigger a function call. Every time a new message gets put in, it triggers the function call and passes the message to it. So 5 databases. 5 databases I interact with on a day-to-day basis in my job, right? The important thing to understand about databases, they always have a server, some way to connect to them, and they always have a query language. That's the big thing. So MySQL Server and MySQL Database, these do run as 2 separate entities. There's the server portion, and then there's the database portion. That's why you can install new servers and not have to worry about the database portion getting contaminated. They do run as separate solutions. There's also the MySQL client. The MySQL client is a bit different. You guys may learn about it as you work in the workforce. It's more for reading capabilities only without writing. No writing capability. Cool. So, like I said, we were talking about IP addresses. We said that these are paths. IP addresses basically describe a location, right? A unique location to you. So how does ports come into play? Well, my IP address is 127.0.0.1. I have Apache running on that address, and I also have MySQL running on that address. I have 2 servers running on the same address. They have to be unique. That is required. They have to somehow have a unique access. So how do we make them unique when they have the same IP address? Well, that's where ports come into play. So a couple weeks ago, some of you had like 3 instances of XAMPP running. You had WAMP running because you guys had installed WAMP. Andrew had some of you install the MySQL server by itself, just the service. So like there was people's computers that literally had 3 instances of MySQL attempting to run at the same time. Here's where the problem lies. All 3 of those were trying to access the same port on the same IP, which means they were in conflict and they were causing each other to cancel each other out. You can't do that. Your services have to run on their own port, and preferably it's even better when they run on their own IP. That's why most big applications don't run databases on the same box that your app is on. They usually run it on a separate box, right? Box being a server or a computer. So ports are super important. IP address is super important because they uniquely identify an entry point to your service, right? To your server. By default, the port number for Apache is 8080. Most web servers are 8080. Nginx is 8080. Ruby is different. It runs on port 4000. the React app runs on port 3001, and the Node Express app runs on port 3000. So those are a little bit different. You can actually override that. You don't have to run localhost on port 8080. And in fact, some people do that as a security measure. They change the port number the server's running on. By default, MySQL runs on 3607. So the whole idea is that if you're going to run other servers, they can't run on those two ports. You can actually run a second MySQL instance. You just need to make sure it's on a different port. All right, cool. Any questions about any of that stuff? No, that stuff's not going to wind up on a test, so don't worry about that. The whole reason I'm explaining this is so that you understand how your Apache server is working, how your MySQL server is working. And this right up here, I do recommend reading it because people who understand that concept can find jobs easier than people who don't, okay? Also here, this is kind of an outline of what happens. When you make the request from your browser, it hits the Apache server with the request. Apache figures out what services need to execute. So you'll notice Apache's like, cool, you want index.html? Tick, 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 takes you to the www folder. Notice it bypasses everything else because you're not allowed access there and looks in here for the file you're requesting. Then the browser's like, hey, I also need MySQL stuff. So it clicks in, grabs the MySQL data. It's only accessing the things it's permitted to access. That is it. It won't access anything outside of that. So that's Apache and MySQL, and that's ports and IP addresses. That's when we get into the play of requests. And this request will wind up on quizzes and tests, just to give you a heads up on actually the embodiment of a request. So, what is a request? Seems like a tricky thing, but believe it or not, you guys have been making requests for as long as you've been using the internet, right? I mean, anybody ever not touched the internet before? Good news, you've made a request. Not only have you made a request, you've gotten a response. Two of the pieces that you need to know about: requests and responses, right? So what is a request? Well, a request is simply when you type in the address in the address bar for google.com, you are making a request to google.com server for some information. That's what's happening. If you don't put anything after google.com, you're asking them for their index file. I want your index file. And you send that off to google.com. Google.com doesn't just want that information, it wants some other pieces of information from you that are important. And those pieces are known as the request package. The request package is a super boring thing to look at, but contains some very important information. The big things we actually care about is what method was used. So method is get. That's super important for us, especially as we develop dynamic websites. What method was used and what path was required. Because the path says, what were you requesting? If there's a file name in the path, so say they were actually requesting /sean.jpg, it would say sean.jpg in that file path. And you can actually use that information to help define where you're going to go. The scheme, not as important, but still fairly important. It tells the it tells the server how it wants to request. It tells it what protocol it's using. I'm using HTTP in order to make this request. And the server will either A, say, no, I deny your request because it's not secure, or allow it if it does allow it, or it might redirect it. Most websites now use HTTPS. The difference is secure or not secure, right? If you hit an HTTP website, Chrome comes up now and says you're trying to access a non-secure site. Do you wish to continue, right? And now there's no reason. There used to be a big reason for not doing HTTPS. It requires you to get a certificate known as an SSL certificate, and they could be very expensive. Some SSL certificates are in the tens of thousands of dollars. They're basically a certificate that says, yeah, these people are legit. That's all it really is. It's kind of a big cash grab. Then this company came out called Let's Encrypt, and Let's Encrypt said, no, this is just something to basically state that you're legitimate. Not everybody needs a $10,000 SSL certificate or even a $300 SSL certificate. So they said, we're gonna open source this, and we're gonna allow everybody to have SSL for free. So then a whole bunch of people jumped on the bandwagon, like Cloud. I'm totally gapping on their name now. Cloud, damn it, I can't remember. It's a really big service. Anyways, they actually allow you to do SSL for free. You can plug your website into it. It takes roughly 10 seconds to do, and you now have SSL. All your traffic goes out on SSL. All your traffic comes in on SSL, and it's free. You have to pay for it. There's a whole bunch of, or you can set up Let's Encrypt on your own server and run it for free yourself as well. That's what we do at G-Shift. We don't pay for SSL. So, but SSL is super important, right? Because that's secure, but that's your scheme. The accept is what you will accept. So this is your browser stating this. It's basically saying, don't give me anything that I'm not allowing. No exe files, no ini files, no bin files, no shell scripts. I just want these particular files. These are the only ones I'm allowing. Then your user agent. Unfortunately, user agents can be spoofed. They're not necessarily accurate, but this basically describes what browser you're using, right? It doesn't explicitly state the browser. It will explicitly state what technologies the browser supports. So it's Windows NT, Windows 64, Apple WebKit, KHTML like Gecko, Chrome, Safari. So it gives a whole bunch of information, nothing to exactly pinpoint what browser or what operating system you're using. However, those details can be pulled by using JavaScript very easily. But you can also fudge them. So it's like a mix. You can't rely on them. So the request packet is sent to the server. In this case, it's unsplash.com. The server will interpret the information, and if everything is okay, then the requested file will be responded with. So the server will pass on whatever the requested file was. There's a lot of different types of request types. So you remember that type I just showed you, get? That's a super thing not to forget. See, gets in that too. Don't forget, get, right? Get is super important. Get is one of the type of HTTP methods that we use to request. The good news is you use get all the time. You don't even realize it. You're using get every single time you type an address in the address bar and hit enter. You're using the HTTP method get instantly. That is the default operation of a browser. A default operation of a browser is to get whatever your request is. The other one that a lot of people may have heard of or may not have heard of is known as post. Post works slightly different, not hugely different, but slightly different. The post method is usually used when you submit a form. Anytime you submit a form, which, I mean, is there anybody here who hasn't submitted a form before? Yeah. Second you submit a form, you are usually conducting a post request. Get and post. What's the big difference between the two? Absolutely nothing. They are basically identical. It's the semantic meaning. You guys heard that word before? Semantic, right? You took HTML class, you probably heard lots about semantics, right? I use section and article instead of div because they mean things, right? I use the p tag because it means this thing's a paragraph. I use header because it means this thing is a heading. I could just use a div, but they don't mean the same thing, right? That's semantics. Semantics basically is describing content. It describes the context of something. So get and post, we use them semantically. We use get when we're attempting to read data. So any data we're trying to access and we just want to read it, we don't want to do anything to it, we don't want to mutate it or modify it in any way, we use get. If we are attempting to delete, update, or create data, right? So the other letters of CRUD, if we're attempting to do those things, then we are using post because we're mutating data, right? Get is for non-idempotent, and post is for idempotent. Those are weird words, and likely the only time I'll use them. So there are other HTTP methods, but unfortunately most browsers don't support them. They're not native to the browser. However, you will see them. So if you use a model view controller system, like next semester when you guys use ASP MVC, or I think you guys even have, in the MERN-Stack class, you'll be using a model view controller system there as well. You will see two more methods that are very common, and those are destroy and patch. Patch is usually reserved for updating data, and destroy, self-explanatory, right? But suffice to say that those two are still just aliases. They're just semantic alias for post. It's still just post. That's all it is at the end of the day. So get and post. Get, reading data. Post, mutating data, modifying data. When we do these requests, we also have the ability to send variables, right? We can send information to the endpoint as what's known as a key value pair. We can say, hey, there's a whole bunch of information. And that's something that you probably would have already thought of. You'd be like, when I submit this post, how does this information in my form get processed on the other side? What happens to it, right? How does it know that my name is Sean? How does it know anything about me? How does that get over there? Well, there's two ways that that data can be transferred over to the other side, to the server. One is using something known as query parameters. So that happens when we do a GET request. It takes all of this data and converts it into query parameters. And you've seen that before. It's one of those really annoying things that you see. All right, this is my go-to to check the internet, whether the internet's working. I type boo, and then I get that. Usually, I don't get scary ghosts. Usually, I get that puppy, this thing, that does not look like a real dog, but for some reason is a real dog. Anyways, when I type that in, look at this big, long address that's up there. See this piece right here? It says question mark. Somebody's using all the chalk. It says question mark Q equals boo. This is a query parameter. It's a key and a value. The key is the Q, and the value is boo. When that goes to the server, I can actually look at that key and grab that value. When we post something like a form, it works a little different. Instead of query parameters, and they all show up in the address bar, when I post a form, they're a little sneakier, right? They're a part of the request packet, but you don't see them. They don't go up in the address bar. They kind of hide their way through the request, make it to the endpoint, and then the server can read those parameters. That's known as a request body, okay? So request parameters are on GET requests, request bodies are on posts, right? There's a common misconception that post is more secure than REST, or than GET. So many people that say that. And it's funny because I thought that as well when I first started doing web development. I thought the same thing. I was like, always use post. It's so much more secure. Bullshit. It's not. It's not more secure. This data, do you know where I got this data from? I got this data by right-clicking and hitting expect on my computer under the Chrome, going to the network tab and looking at the request as it was posted. It's not secure. It's no more secure than up there, except for the simple fact that people can't see it over your shoulder. That's really the only security you get there. Security is done in two locations. One, if somebody's looking over your shoulder, elbow them, right? And two, we use SSL, right, to stop something known as a man-in-the-middle attack, where people actually listen to that request within the middle. That's how we deal with security. Don't rely on post as being secure, because it is not. It is not more secure than GET. All right. That is a lot of information. The only thing I expect you to kind of study and know would be that one little bit of lecture about GET and post. That's it. And I will actually put that on the next quiz so that you can practice it. Otherwise, we're into fun stuff now. Well, depends. We might have differing terms of fun. We're going to learn about phpMyAdmin. Good news. How many of you used Workbench? You guys are using Workbench, right? MySQL Workbench. You're not doing command line, are you? Like, are you guys typing raw queries in the command line? No? See, you would if I was doing it. You'd be typing raw queries in the command line because that's the best way to do it. It's so much faster than Workbench. However, when you do PHP development, so common you're going to see this tool, phpMyAdmin, probably the most common tool you will see. What is its purpose? Its purpose is to allow you to interact with your MySQL database, set up new tables, set up new databases, all that type of stuff through an interface. So you can do everything we're going to do from the command line. Every single thing can be done from the command line. And I would argue it's much faster. But we're going to use the GUI because it will be more comfortable for most people. And I don't feel like showing you how to use the command line because I think that would be a bit of a train wreck. So the easiest way to open this tool, unfortunately, if you don't have access to this little window, you have to do a different step. But just simply click on the phpMyAdmin option, okay? If you don't have access to that, all you need to do, whoops, that's not what I want. Go away. If you don't have access to that, look at the address up here. It says localhost phpMyAdmin. I'm going to just post that right directly in my browser because I don't want to use Internet Explorer because I hate it. So it's localhost phpMyAdmin, all lowercase letters, and enter, and it'll take you to the screen. So localhost phpMyAdmin. The default username is root. There shouldn't be a password unless you've set one up, and if you have set one up, it's either the one you chose or the default one will be root, which means it will be root. Don't choose any other options. I think you can only choose MySQL. We're just going to use MySQL and click Go. Okay? So type in root under your username and click Go. That'll take you into the phpMyAdmin database folder. That's alarming. Where's my database? Huh. Oh, right. Never mind, I remember. All right, we're going to install our database. So we're going to create a brand new database, super easy, so super easy, it's not even funny. These things in this list on the left here, these are the databases that are already there. One is about the schemas that are built in, one is about MySQL, so that's where your users will go, performance schema, and the SIFs. We're not going to use any of those. So the default databases that are used for managing MySQL. We're going to create a brand new one by clicking on New. So we're going to go over to the left here, highlight New, and we're going to click New. Should be no password by default. If there is a password, it's likely root. R-O-O-T. Yeah. There shouldn't be a password. There isn't usually. Usually it's just root. Yeah, there's no password. It's just root. All right, so go ahead, and once you're in there, click on New. The database name we're going to create, everybody's going to create the same one. It's COMP_1006. Make sure you do an underscore. I had a student last week do a dash, and then they had a world of problems because they had to quote their database name. So comp_1006. Where it says Latin Swedish CI, we're going to change that to UTF-8 towards the bottom. UTF-8 General CI. I'll leave that up there for you. UTF-8 is your character encoding. It's how it actually encodes the characters that go into the database. If you have a different language format, then you would obviously use that different language format. UTF-8 is the most common. So comp 1006, and your database language type will be UTF-8 underscore general CI. It's still phpMyAdmin, I believe. Hit enter. I believe it is. Yeah, same one. In fact, you're already logged in though. Yep. That's fine. Just go to localhost / phpMyAdmin. So open up a new terminal. Yeah. Localhost / phpMyAdmin. You actually already have it down there on the left. Yeah. Click it. Try http:/localhost / localhost. No. Go back into your address bar. Address bar, that's your search bar, bud. Address bar. Type http. Yeah. : / No, you're totally in weird areas now. I don't know what's happening. / localhost / phpMyAdmin. Hit enter. Hit refresh again. Let me see your keyboard for a second. Move your hand. That server is definitely not running. So this will basically kill everything that's running. Because you don't have anything weird running. What's Web Companion? I don't know what that is. That might be causing an issue. There you go. Yeah. Are you good? All right. Okay. So once you've actually created those steps where you wrote the comp 1006 database there, and you chose UTF General CI, you're going to click Create. What's up, bud? Click New? Yeah, hit Go. No, that's not the issue. There's usually a logout button somewhere around here. Log out? Log out over here. Yeah, log out with a little door. Yeah. This one? Nope, that's it. Yeah. Okay. Hit. Are you sure you have a password? Yeah, the root. Yeah. Okay, click Go. Oh, you got some serious issues here. You're also missing things. Many directories on my code. What are you using for your database here? Just the one. Yeah, both of them. You've got something running. You've got like MySQL 80 running or something. I bet you there's like 3 databases running here. Oh yeah. Yeah, you've got MySQL NT running. All right. what's happening is this one is causing issues with the other ones. Remember how I was saying about the server? The port number for it is restricting the other one. It's likely going to cause issues, so we'll restart all the services. A little bit of a better sign. No, the site can't be reached. You're definitely crashing. Awesome. That's because this database doesn't have a password.
Oh.
Now you can do it. So what was happening is you were actually connecting to that other database. Yeah, and that's what was causing the issue. Exactly, yeah. All right. So hopefully you've clicked on new. You've chosen to create a comp_1006 is the title, and the database's language encoding is UTF-8_general_CI. Once you're done that, click create. And the database will be created and it will take you to this page. Now, I am not going to go through the painful steps to creating our massive user table. Instead, we're just going to import it because it's so much easier. This stuff of understanding, data types in MySQL, understanding how to create all those different things is not a me job. That's an Andrew job or a Ben job. They will teach you the data type pieces. The only thing we're going to concern ourselves is reading that data using PHP, okay? We're not really going to concern ourselves with what's in the table. So we are going to take advantage of a big SQL thing I wrote for you. If you go to here, lesson 3, where it says starter files, I want you to click that link. Click the starter files. It's going to download them. And it's going to put them into your downloads directory for you. Remember what I was saying about Apache? Our files have to exist in that directory, right? So they have to go into what directory? Exactly, the comp1006 or the www directory at the very minimum. But they have to exist in that directory so we can access them. So we're going to take this folder, we're going to copy it, and we're going to paste it into our comp1006 folder that we pinned. So open up your File Explorer, and on the left-hand side, click Downloads. In there, you should see the Lesson 3 zip folder. Click on the Lesson 3 zip folder, right-click, and choose to copy, or hit Control-C. Hopefully you have the link pinned. Those of you that have the link pinned, just go ahead and click it. Those of you that don't, you're going to have to go to this PC, click on C, click on WAMP64, www, comp1006, right-click, and paste the lesson zip in there. We're not quite done. We need to extract this folder. So double-click it. Nope, sorry, don't double-click it. Right-click it and choose to extract all. And we're just going to choose the default that it says and click Extract. When it's done, you should get this Lesson 3 folder in here. The only issue we would have is that we'll have, no, that's fine, actually, I think. Yeah, we have 2 Lesson 3 folders now. We want to make sure we only have 1 Lesson 3 in our path. So there's a couple ways we could do this, but the easiest way is to just select everything in that folder, copy it, go up a directory, and paste it. That way they're in that root folder. Yep. Good? All right. You need me to do it again? Yeah, do it again. Let's go over this one more time here. I'll get rid of my lesson 3 folder. All right. You have your zip file inside that directory, right? In the comp 1006 directory. You're going to right click and choose to extract all. Cool. Did you find extract all? Is it a zip file? Maybe you've already extracted it. Because you have a different unzipping thing. That's totally fine. Just hit OK. There you go. Oh, okay. All right. Hades meeting new people. All right. We're going to extract that. So yours looks different. That's fine. All right. Your next step, bud. Your next step, go into that folder. Highlight all those files. Right click and choose copy, or just hit Control C. That also works. Okay. Go back a directory. So that you're in this folder, and hit Control V and paste those files. And when you've done that, you should have those 3 files and a lesson 3 folder in there still. Is that what you have? Cool. All right. The last step is to get rid of this lesson 3 file folder because we don't need it, right? So just click on it and delete it because we don't need it. Good? All right. All right. Everybody okay? Awesome. Let's import our SQL file so we can create all of our users. Now, I painstakingly wrote all of these users in one by one. I'll show you what the file looks like. Took a really long time. Sat there for about 3 hours. Just wrote all these users out. How many people believe that? No, I didn't do that. So I used this library called Faker. Faker's pretty cool. Faker, I created one person with Faker and then told Faker to run that 103 times. And Faker generated 103 brand new users for me. Took me like 10 minutes to do. Yeah, it was pretty fast. All right. I'll show you Faker if we have time later in the semester because Faker's pretty handy. We're going to import that. So go back to your internet browser. Make sure you're on phpMyAdmin, and you'll see the import button, that one there. Click on import. We're going to choose the file, so click choose file. And either navigate through to C, blah, 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 so you finally get to this folder and click on the comp_1006 SQL file. Comp 1006 SQL. And click open. Right? Don't worry about any of the settings. They can stay the way they are. All you're going to do is scroll to the bottom and click go. Yes. Give me 1 second. Click go. Oh, I have an error. You shouldn't have an, oh no, you will likely have an error. Yeah, we can fix it. So open up that SQL file. Right click on it, choose to open with code or whatever your visual editor is so that it opens up in here. Okay. Once you have it open where it says use comp_1006, that's what it should say actually. Why is it trying to write to comp 1006 Wednesday? That doesn't make any sense. Did I import the incorrect file? Is that what happened? Hold on, let me double check. got so many directories open here. I've used underscore comp 1006. Oh, I know what I did. Try that again. Choose file. I'm under the wrong directory. You're under the incorrect directory. And then click go. Now it's working. Did yours work? I think it would have. Click continue. Because you didn't create a new database. Click on Nueva. And then change that to comp underscore 1006. C-O-M-P. M-T. You have too many O's. Nope. MP underscore. Nope. Get that space out of there. Underscore 1006. Change stop because you're going to click something. Change that to UTF-8. So towards the bottom. It's this one. General CI. Yeah. And then click create. Awesome. Now do your import. Go find your file and go ahead and import it. Yep. No problem. All right. There was a hand up over here. All right, bud. What's up? You need to create the database. You're missing the database. Click new. What's the mess? The whole thing's messed up, actually. Your whole browser is messed up. There we go. New. Oh, yeah, you're there. Database, COMP underscore 1006. This is going to be UTF-8. And we're going to do general and create. Awesome. Import. Browse. C drive. 64. www. Comp 1006 lesson 3. Comp 1006. There we go. Go. Stop. All right. So once we have our database created with our users, we can actually visually see our users. All we have to do is go look at the table. If you look at the left, you'll see your Comp 1006 database. If you click on it, it should open up and you should see the users table on the right here. If you click on the first link in that users table, you'll see the list of all the users in this wonderful table, right? I heard voices somewhere. No? Okay. All right. So now our next step is to actually see this data visually to us. So before we do that, why don't we take a small break? I'll recharge my AirPod a little bit, and then we'll start up again, and we'll build the index file, and that will put us in line with the class from last Wednesday. All right, so let's take a 10-minute break.